Okay, so I've already mentioned this to some people, possibly, but this section is all about parallel lines and the proportional parts they create. If lines are parallel, then the short pieces are also proportional, meaning, for example, if I have this, and you'll notice the parallel markings there, hopefully, then this piece, let me just do it like this piece, is proportional to this piece the same way this piece is proportional to that piece. So you can, and also you can see that these triangles have to be proportional because using parallel lines, that angle has to equal that angle because they're corresponding, and that angle has to equal that angle because it's corresponding. So we have two triangles that are obviously similar because the two angle theory from last section. But we can use what I said a second ago. I'm going to go ahead and mark these out. That's 15. PS is 12.5. That's a horrible 0.5, but we're going to ignore that. That's 5. And I'm looking for TQ, which is down here. So the ratio of 12.5 to 5, you'll notice here and here, has to be equal to the ratio of 15 to x. Do note how they go in order. This one was first, so this one's first. Then we do our cross multiplying that we've done before. 15 times 5 is 75. And x would have to equal 6 if you use a calculator. Or this way I did in my head was 12.5 times 2 is 25. So that's times 2 to get 25. Times 3 gets me 75. So 2 times 3 makes 6. That doesn't make sense. I apologize. You can think through it your own way and hopefully get there the same way. The inverse is true of the theorem at the beginning of the note. At the beginning, if you find them proportional, then the two sides have to be parallel. So if we go through this, so I know DG is half the length of GF. So I'm just going to call it 1 half of X. I'm going to call that X. And I know that EH is 6 and HF is 10. So 6 over 10. Well, that simplifies to 3/5. The x's cancel. This is actually equal to 0.6, which is not equal, so these lines are not parallel. Okay? That's what it means. If they're not proportional, if the proportion doesn't work out, then they can't be parallel. If you didn't understand that math, you could have also done the cross multiplication, right? So you get 6x when you multiply this way. And 10 times half of x, well, half of 10 is 5. Those aren't equal still, so I still get the not parallel. Triangle mid-segment theorem. A mid-segment is parallel to one side, and it is half the length. You remember we talked about mid-segments, hopefully, in trapezoids? But you can see that if this is parallel to this, then it even kind of looks like it may be half the length where this piece added together could be the whole one. Hopefully it looks that way at least. So it even tells us SA and AR are mid-segments. And we're told that BS right here is 18. And that SA is 10. Oops. And that SAR, which is right here. Find the values of BE, AR, and the angle ARE. So right there. Okay? First off, let's do BE, because BE is actually easiest. Because they told us that if SA is a mid-segment, it has to be half of this length. Therefore, since SA is 10, BE has to be 20. Okay? Now I want to talk about this. Mid-segments, if you remember from trapezoids, have to go to the middle of the triangles. So, that's what a mid-segment's defined as. So this length is half of the whole. And since this is half of the whole, we can also say that AR has to equal 18. And then if we go here, and I'm going to draw my parallel lines and draw this. this angle and this angle are alternate interior, therefore angle ARE would have to equal 70 degrees. Okay? Once again, if I talk too fast, feel free to pause me, shut me up, whatever you need to do. Oh, darling. Whatever works to help you to understand it. I do know there's some people that watch the videos 2 or 3 times. If it takes that, please do it. The parallel lines thing still applies if we have multiple lines parallel. So, like in this example, AB would be still congruent to BC, and EF to FD, and also we'd have, technically we could have, if I call this point down here, like, we'll call it J, because I know I don't have J. I could do CJ over BC, and that would have to be equal to DJ, funny, over FD. And you could go longer, technically. You could do AB over AJ, and then EF over EJ, etc., etc., etc. There are lots of different proportions that you can set up there. So, we're going to use this picture to kind of help us out. If 3 streets are parallel, first, second, and third, so we're going to call that first, that second, and that third, and they intersect Maple and Broadway, let's call this one Maple, and I'm just going to put a B for Broadway. Find the distance between first and second on Maple if the distance on Broadway is 26 feet on first and second. So, this will be 26. And 13 feet between second and third, so that's 13. While Maple has 16 feet between second and third. So we can kind of see how we're setting this up. We have 26 over 13, and then x over 16. First thing I would do is simplify this. That goes to 2 over 1, which will make this easier, because we have 32 equals 1x, so obviously the distance is 32 feet. It seems a little short, but it's okay. If you have any questions, you can always email me or come see me. Otherwise, have a good evening, and I will see you soon.